All right, circle review for the EOC. So the equation of a circle is x minus h squared plus y minus k squared equals r squared, where the h and the k are the center for the circle and the r is the radius. So state the center and the radius for each problem. So this is our equation of a circle. The center, you get that by asking yourself, what number plus 5 would equal 0? Negative 5 plus 5 is 0. What number take away 3 equals 0? Positive 3. You'll notice that it's essentially a sign switch. And then here, this is really r squared. So if we want to know what r is, we square root the 25, which is 5. For part B, once again, if we want the center, switch the sign, so it's positive 2. Switch the sign, so it's negative 6. So here's the center of the circle. Once again, we're going to square root this value to find the radius. Since you square root 7, you get a decimal. We're going to leave it as the square root of 7. For part C, we have, once again, for the center, switch the sign. Now this one, you'll notice there isn't a number with the y squared. Therefore, the number for the y is 0 for the center. And then, once again, this value we square root to find the radius, which is 10. And then for D, the center would be 0 because there's nothing going with the x squared. And then we would have a positive 5, and our radius is the square root of 5. Because when you try to square root 5, you would get a decimal. The center is negative 2, comma 3, and the point on the circle is 1, comma 5. Write the equation of the circle. So if we plot this point, negative 2, comma 3, here's our center of the circle. The point they mention is 1, 5. This is actually on the circle. So what we need to do to figure this out is to figure out what the radius is. To do that, we're going to make a right triangle. And we can count, this is 1, 2, 3, a distance of 3. This is 1, 2, distance of 2. And we're going to use the Pythagorean theorem to find the hypotenuse, which in this case is the radius of the circle. So we have a squared plus b squared equals c squared, where the c is the radius squared. We'll make b be the 2, and we're going to make 3 be the a. We're going to get 9, 4. We have r squared, and we're going to add those together. We're going to get 13 equals r squared. You'll notice our equation has r squared, so our equation is going to equal the 13. And now it comes to writing in the center for our equation for our circle. For x, we're going to take the negative 2. We're going to switch the sign, so it's x plus 2. For the y, we're going to take the positive 3, and we're going to make it subtract 3. Now we have the equation of the circle. So this is to review the concept of central angles and arcs. So to go over that topic, your central angle would be located here in the middle, in the center, and its arc is out here. Now a central angle and its arc are always the same degree. So over here where we have a 72 degrees for this arc, its central angle right here would be the same of 72 degrees. So that's the concept between central angle and arcs. So we're going to go around and find all the degrees and angles, all the arcs and angles for this circle. So these two angles are known as vertical angles. They're exact opposites of each other. So this right here would also be 72 degrees, and therefore this arc is also 72 degrees. To find, say, this angle right here, you may notice that UW is a diameter, which means this is half of a circle, which is 180 degrees. So if the whole half that circle is 180 degrees, and you know 2 out of the 3 angles that make up half the circle, you can find this one right here in the middle by going 180 degrees minus the 72 degrees minus the 87 degrees. You get 21 degrees. So this little angle right here in the middle is really 21 degrees. And therefore, its arc would also be 21 degrees. So the last piece that we're looking at is this angle over here. So once again, if this is a diameter, that means this down here is 180 degrees. So if we know it's 180 degrees and we know the angle to the right of it is 72, 180 minus 72 is going to be 108 degrees. So this right here is 108 degrees. Therefore, its arc is also 108 degrees. So now that we actually know all the central angles and all the arcs, we can just list the information here on the left-hand side. So angle UXV would be 72 degrees. Arc ST is 21 degrees. Arc VW is 108 degrees. WXV, its angle is 108 degrees. Arc T, we go to V all the way to W, so we are going to add up all these degrees. So 87 plus 72 plus 108 is 267 degrees. And then the arc SU, that's from here to here. We care about these two. So 21 plus 87 is 108 degrees. So here they're asking us to solve for x and then find a specific angle. So we need to figure out what x is, and one way to do that is we can notice that this angle right here that I'm marking in purple is a vertical angle of this angle right here, which means they are the same degree. So this angle and these two combined are going to be the same. So this is 103 degrees because its arc and the central angle are always the same. That means over here, these two angles must add up to 103 degrees. Well, the 15 degrees in this expression is what creates the arc that goes with that central angle. And that big arc there in purple should be the same as its central angle, 103. So I can make an equation that says 18x minus 2 plus the 15 has to equal 103. So now you just solve the equation. You're going to have 18x plus 13. We want to minus the 13 over, so we're going to get 90. We're going to divide by 18, and x is going to equal 5. So now that we know what x is, they're asking us to find the angle DIF. To do that, first we're going to need to figure out what arc DE is. So we can go ahead and do 18 times 5 minus 2. So 18 times 5 minus 2 is 88. So we now know that this right here is 88 degrees. What we don't know is this, but we can find it. We can see that this is 15 degrees because that's the same as its arc, and these three right here should add up to 180. So if I go 180 minus 88 minus 15, I can find out that angle with the question mark. So 180 minus 88 minus 15 is 77. So we know this is now 77 degrees. Now that we know that's 77 degrees, they're asking for our angle DIF, so this yellow one. So we're going to take these 2 degrees, the 88 and the 77, and we're going to add them together for 165 degrees. And that's the angle DIF. Okay, talking about inscribed angles. So I had to put ones that are a little bit tougher on here, so you have some good examples of the harder ones. Keep in mind that the relationship between a inscribed angle and its arc, so if this was a 20 degrees for the inscribed angle, the arc would have to be 20. If you go from the inscribed angle to its arc, you got to multiply by 2. And if you go from the arc to the inscribed angle, you divide by 2. So in this case, the one on the left, I've got a 46. I want to know what this angle degree is. So I'm going to go ahead and take that 46 and I'm going to divide it by 2. So I'm going to get 23 degrees. So now I know this angle here is 23 degrees, and it also has this expression for the same angle. Now I can set these two equal to each other because they are representing the same part of this diagram. So 7x plus 9 equals 23 degrees. I can go ahead and minus the 9. I'm going to get 14 divided by 7, and I learned x is 2. Over here on the right, if I want to solve for x, I actually need to figure out what this arc is. To do that, if this is 59, if I'm going to go from the inscribed angle to the arc, I'm going to times it by 2, and I get 118 degrees. Now you'll notice that I have a full circle here, and a full circle has 360 degrees. And so if I take this, this, and this, I can make an equation of them all added together to equal 360 degrees. So I have negative 20 plus 75 plus 118. I have 173. Going to minus the 173 over. I'm going to have 187. Divide both sides by 17. And x ends up being 11. Once again, utilizing the idea of inscribed angles. If I want to know, say, angle P, angle R, angle S, we can kind of start in many places. If I want to know one of our concepts for a quadrilateral is that the angles opposite of each other need to add up to 100. Needs to add up to 180 degrees. So 180 minus 93 is 87. And if I take, so I now know what angle S is. And to help me find the others, I actually need to find some of these arcs out here. So if I look at angle S and I follow the sides of the angle, I can figure out what this entire arc is. So 87 times 2 is 174. Now I need to know what this arc is right here. To do that, if this section is 126, but the whole thing is 174, if I subtract them, I learned that this section is just 48 degrees. Now that I know that, I can figure out what this arc is, SR, since we know all sections of the circle except for this one, and the circle has 360 degrees. I'm going to take 360, and I'm going to minus all the arcs that I do know. So 360 minus 126 minus 48 minus 90, you're going to get 96 degrees. So now I know this arc is 96 degrees. So if I want to find the angles, say angle P, if I just start here with P, follow the lines, I'm going to see its arc is made up of the 48 and the 96. So 48 plus 96 is 144. And if I want the inscribed angle, I divide that by 2, getting 72 degrees. Now that I know that's 72 degrees and the angles opposite of each other should add up to 180, 180 minus 72 is 108 degrees. So this is 108 degrees here. And that's that concept, once again, of inscribed angles.